So we have to start with first chapter, that is geomorphology. Yesterday we have done introduction part, that is how is geography divided. We are having two segments of geography, that is physical and human geography. Physical geography, this is world physical geography, wherein we have three divisions for world physical geography: geomorphology, the climatology and oceanography. So I have given you syllabus for the first part, first chapter, that is geomorphology, right? Online students, is it audible? Fine. So we'll begin with the basics of the geomorphology. So geomorphology is, see, geo is earth and morpho is a structure, right? And logy means study. So geomorphology is the study of structures that belong to, so it is the study of structures of the outermost layer of the earth. Outermost layer of the earth is known as lithosphere, right? Now what is meaning of lithos here? Lithos is rock, right? So lithosphere is the outermost solid layer of the earth. Solid layer of the earth is known as lithosphere. The study of structures that belong to the lithosphere is known as geomorphology. Now, what are these structural features referred as? The structural features are referred as landforms, right? So, what is a landform? These are the features present on the surface of the earth, or structural features of the lithosphere are referred as landforms. So, here form means again structure. It has a structural identity. Okay. So geomorphology is a study of structural features of the lithosphere. Lithos means rock, and these structural features that are present on the surface of the earth are referred as landform. So how we define a landform? Landform is the feature on the earth's surface which is composed of rocks, and it is natural in origin, and it is a part of a lithosphere, right? So how we define landform? Landform is a feature present on earth's surface. It is composed of rock, made up of rock. Composition is rock composition, and it is evolved by some natural phenomenon. Natural in origin means not created by man, natural in origin, and it is a part of the lithosphere. This will be referred as landform. So how is the surface of the earth? Look at the surface of the earth. The surface of the earth appears in this way, where it is not flat, right? How is the, now you take any continent, how is the surface of the continent? It is not flat. There is lot of unevenness on the surface. So we can say that there is non-uniformity on the surface of the earth, right? There is non-uniformity on the surface of the earth. The surface of the earth is not flat, right? Now this non-uniformity is because there are different types of what? Landforms. Now you see, here is a mountain. This can be treated as landform. Then this can be another hill which can be treated as landform. This is a plain which is landform. This is another mountain which is landform. In this way, the surface of the earth is a combination of different type of landform. So what we can write, the non-uniformity of surface is because of complexity and diversity of what? Complexity and diversity of landforms, right? Note there, the non-uniformity of Earth's surface is because of complexity and diversity of landforms. Okay. Now, what is meaning of complexity here? What do you mean by complexity? The evolution of landform is not simple, right? When you say that this is one landform, what is this? This is some mountain, right? Mountain can be treated as a landform, right? So this mountain, how this mountain has come into existence, this has not evolved by a simple process. It is a product of multiple processes, right? Therefore, it is known as complex. So, complexity in evolution of landform. There is complexity in evolution, means landform is a product of multiple processes. Landform is a product of multiple processes, right? So it is not that only one process might have resulted in formation of the landform. And what do you mean by a diversity of landform? Diversity means no two landforms are what? No two landforms are identical, right? No two landforms are identical, even though they are located in the same region. No two landforms are identical. There is no similarity between any two landform, right? Even though they are the part of same region, same place or same location, right? For example, you say that this is the peninsular India, right? Now in peninsula, what you have? This is Western Ghat. Western Ghat can be treated as one landform. Then you have, this is Eastern Ghat. Eastern Ghat is another landform. So both the landform belong to the same region of peninsula, but are they same? No. They are differing in height, they are differing in composition, the slope is different, steepness is different in this way. Now you can see here, this one is Vindhyas and Satpuras, again the same region, but they are not identical. So this is the meaning of complexity and diversity of landform, right? Now, so this is a landform. Now when you look at identity of any landform, how we can say, or what is the identity of this landform? So this is a region, assume, which consists of this type of features in this way. This is a part of a continent which is consisting of a mountain here, right? So identity of any landform is because of its elevation measured from some reference level, right? When you say that this is a landform का मतलब ये है, it will have some variation in height, variation in the elevation which is measured from some reference level. What is that reference level? Reference level is known as base level, right? Reference level is a base level. So what is a base level? A reference level to measure the elevation of the landform. So here elevation is measured from the base level. The base level is a reference level to measure the height of the landform. So here you can see, here is, this one is considered as a base level. So what is a base level for a continent? Base level for a continent is a sea level, right? If landform, you are measuring a landform that is lying on the ocean floor, then sea level cannot be a base level. There should be abyssal plain level that is considered as a base level. So base level, so we are using a general term which can be varying. For a continental landform, the base level is sea level. For a oceanic landform, the base level will be different. So base level keep on changing depending on what is our what type of landform we are considering, right? So for a continent, the base level is a sea level. So a landform has an identity. First is elevation. Now, how much is the elevation of a landform from the sea level? We are considering continental. So from a sea level, this will be referred as what? Relief, right? What is relief? Relief is a height of a landform measured from the sea level, right? Important terms. So relief is the height of a landform. And second identity of any landform is what? Slope, right? Second is its slope, that is inclination of the landform with what? Base level. How much angle that landform is making with the base level, that will be known as slope. So this is, we can take it as theta, is the angle or inclination made with the base level, right? Inclination with the base level. Now if I take both become 0, क्या होगा? Slope is 0, elevation is 0, क्या होगा? There is nothing, no landform exists then. So if these two are 0, the relief is 0 and slope is also 0, there is no existence of the landform. So existence of the landform itself is because of these two factors, that is relief and slope. Okay? So theta is the inclination, theta is the slope. Now how much is the height? So you take this landform, this is one landform x, right? And how much is the height of this landform measured from the base level, right? So you say that the height is, so base level is O, is the base level, and this is the height of the landform here. So OA is the relief of the landform. So this is point A. So OA is the relief of the landform, and this is known as absolute relief of the landform. So what is absolute relief? The height of the landform measured from the base level or sea level, that will be considered as, from the sea level, this will be considered as absolute relief. So if I say that this is 2000 meter, the peak of this landform is 2000 meter, this will be known as absolute relief, right? Now what is the height of this landform measured from this location y, right? What is y? Y is the nearby valley, right? It is the nearby lowest location. तो यहाँ पर reference location क्या है? Reference location is nearby lowest location, and we are measuring this. This one is, let us say, this is known as the relative relief, right? So relief is of two types, right? Relief is of two types. One is absolute relief. Absolute relief is always measured from sea level, and what is relative relief, which is measured from the adjoining location. This will be known as the relative relief, right? Take example, suppose you say that Mount Everest, right? Mount Everest has the height of, round figure, 9000 meter. So ये जो 9000 meter you are describing for Mount Everest, this is with reference to what? sea level, है ना, with reference to sea level it is 9000 meter, मतलब this 9000 meter is which type of relief? Absolute, right? It is an absolute relief. But if you are climbing on the Himalayas like this, so this is how the height is increasing. This one is the Mount, this is the Mount Everest, right? Now this Mount Everest, no doubt the highest peak is 9000 meter, but if you take the nearby lowest location, right, this height will be only how much? 2000 meter from the base camp of Mount Everest. ये क्या होगा? This will be considered as relative relief, right? So relief is further classified as, here you can write absolute relief and relative relief, right? So variation in height measured from the nearby locations will be known as kya? Relative, right? So have you written this? Absolute relief is the elevation, right? Absolute relief is the elevation measured, absolute relief is the elevation measured from the sea level, while relative relief is measured from the adjoining reference locations. Relative relief is measured from adjoining reference location. ठीक है? Now, so what we got here? The identity of any landform is because of relief and slope, right? Relief is further classified as absolute and relative relief. So now, how is the surface of the earth? So we have, this is one landform. So landform L1 which has relief R1, right? Then you can say this is another landform R2 and L2 and R2. This is some valley, this is L3 and this is R3. So all these are considered as landform. So from this point X to this point Y, if you travel from X to Y, what you are getting? You are getting a difference in height, right? It is not smooth, it is not continuous, it is not uniform from X to Y. There is variation in height caused by multiple relief feature. This change is referred as, what is this referred as from X to Y? This will be known as topography. Variation in height caused by multiple relief feature measured between the two location is known as topography. So I say a topographical map. Topographical map का मतलब क्या होगा? It is describing how the height varies from between the two location. It is a topographical map of Brazil. का मतलब ये है between the two ends. How is the height varying? Means how is the difference of the landform between the two location? Right there. Topography. Topography is the variation in height. Topography is the variation in height caused by multiple relief and combination of landforms. Multiple relief and combination of the landforms. ठीक है? So we got an idea of what is meaning of landform, what is relief and what is a topography. ठीक है? Now assume that this is some mountain and this is the mountain structure. ठीक है? इस तरह से एक mountain है and this is the height of the mountain measured from the sea level. तो ये क्या है? This is the absolute relief of the mountain. ठीक है? So we take sea level as O and this is A. Is a OA. OA is absolute relief, right? OA is absolute relief. Now this mountain here also has a valley in between. There is a valley, right? So this point is X and this point is Y, right? Now this difference between X and Y is known as relative relief. ठीक है? अब देखिए, if there is one river which is flowing from here, right? ये एक river है which is located in a valley, right? I'm just giving you general idea. So what this river is doing? River is taking the material from the valley and transporting it. This process is known as erosion, right? Erosion we'll be discussing in detail. So river is causing erosion here, and assume that what is happening to this material, all this material falls down and this is transported by the river. What is happening to the depth of the valley? The depth of the valley now has increased, right? So initially the valley was here, now the depth of this valley has so initial valley was here, now it has increased. This is known as valley deepening, right? Valley deepening हुआ है यहाँ पर. So what has happened between X and Y? X and Y distance was this. Now where is Y? Y has come here, right? It was here, now it has come here. So valley deepening में what is happening to this absolute relief? Did it get modified? No, height of the landform has remained same. If you make an observation from far, if you are observing that landform, right, you find that the height of the landform is intact, right? मतलब absolute relief is constant, right? Absolute relief is constant. What got modified? Relative relief got modified by the erosional work done by the river, and this is known as valley deepening. अब valley deepening जब होगा, tell me, absolute relief is increasing or decreasing? Absolute relief is constant. Relative relief is increasing or decreasing? Yes, online students. Relative relief has increased. Valley deepening has caused increase in relative relief. Now this material, it was here, now the river is at this point. After this, what the river does? Again takes the material and deposit. Now what is happening to the height which was at X has come to X1, right? X to X1. इसमें क्या हुआ है? The absolute relief has decreased and relative relief has further increased, right? अब देखिए, when this X1 is brought to X2 and here it is now, this is the height of the landform, X1 to X2. क्या हुआ है? The absolute relief has decreased, but relative relief also has decreased, right? What is this process? यहाँ पर क्या हो रहा है? See, when it is like this, this is known as valley deepening, right? When it is happening in this way, this is known as valley widening, right? So when it is valley deepening, what is happening to the relative relief? Increases. Valley widening, relative relief is decreasing, right? I hope you are able to understand this. So note there, we will be discussing in detail, just as a reference it is required here. The process of valley deepening, the process of valley deepening will cause increase in relative relief. Don't worry, I'll elaborate these things ahead. So process of valley deepening will cause increase in relative relief, and valley widening will result in reduction in relative relief. Underline there, valley deepening and valley widening, these 2 points. So now what we have, the surface of the earth is not uniform. It consists of difference of landform, right? Thus, for the purpose of study, we need to classify the landform. So note down there, the classification of landforms. How we classify the landform? When we say that there are multiple types of landform, multiple relief of the landform, we have 2 criteria to classify the landform. First is, we classify the landform based on their size or area they occupy on the surface of the earth. This is known as order of the landform, right? Order is based on size. Now here we have first order landform. What are first order landform? Those features which are largest on the surface of the earth. Jaise, what are the largest features on the surface of the earth? Continents. Continents are categorized as first order. Then you have the second order landform. Second order landform is, first order क्या है? Largest है. If you see the surface of the earth, what you find as the largest landform is a continent. Continent के ऊपर, what is smaller than a continent? Now you can consider here ocean as well as, continent as well as ocean basin also as considered as first order landform. If you remove water, what is there? There is one large depression, right? That also is treated as first order. But here we will take more because we are studying the continents. It is continent as first order. Then next largest feature will be the fold mountain, right? Mountain chains, fold mountain. These are the largest mountain chains of the world. Fold का मतलब है they are caused by compression, convergence, bending, right? Compressive force. Now we'll see in plate tectonic. So जैसे here we have the mountains like Rockies, Andes, Alps and Himalayas. These are all considered as the second order landform. What is happening to the third order? Third order can be like plateaus, right? Plateau or plains. These are all considered. Plain is also landform, right? Because plain also can have, yes? Plain also is a landform, yes or no? Because plain also has relief and plain also has slope, right? Plain also has. So it is not that plain means it is perfectly flat, right? So a third order is plateau and plain. Then fourth, fifth, sixth, seventh, eighth, क्या होगा? As we move down, the size of the landform goes on decreasing. यहाँ पर ये दो याद रखिए. What is first order? Continent. Second order is fold mountain, right? You may get, see, instead of writing a fold mountain, asking a fold mountain, UPSC sometimes tend to place this word, that is second order landform or first order landform, right? So you should know what is meaning of this. Now we are classifying the landform. First is based on size and second is based on origin, right? What is origin? Genesis, right? Origin or genesis, formation. How are landforms created? Landforms are created by, first thing, origin of the landform is by the cooling of the crust, right? Cooling of the crust. It means that the beginning of formation of the landform was with the formation of crust itself. What is crust? Outer layer of the earth, right? When the crust was formed, the crust formation itself was it flat? The formation of the crust itself was uneven. The solidification of the crust itself was uneven. That led to a small features on the surface of the earth. The continents that were created by the solidification of the crust are referred as proto-continent, right? Proto-continent का मतलब ये है that the small land masses that came into existence when the crust was created, right? So there is a process of accretion. Accretion का मतलब accumulation. All these land masses might have come together and that led to one large continent that was known as supercontinent. That is known as Pangaea. Pangaea got divided, right? And that then we have the present arrangement of the continent. In this way it has operated. पहले क्या बना था? Proto-continent. The proto-continent got assimilated to form a supercontinent. The supercontinent again got divided, right? And we are having what we see today on the world map as North America, South America, Eurasia, Africa and other parts, right? So origin of the landform is, first thing, it is because of unevenness of the crust itself. Number two, the landforms are created by the force that originates from interior of earth. What is this force known as? Endogenetic forces, right? Endogenetic force originating from interior. This is known as, this can be a reason for landform. And third, landforms are also created by exogenetic forces, right? Exogenetic force. जैसे take example, mountain building. Mountain is created. What is creating a mountain? Which force? Endo or exo? Endo is creating a mountain. So you say that this is the formation of Himalayas. Himalayas are created by endo. Now there is a river flowing in Himalayas which has created one valley. Valley is also a landform. This valley is the result of exo, right? Valley is the result of exo. So endogenetic, what is the difference between the landforms that are created by endogenetic? Endogenetic forces are responsible for macro landform, macro in the sense large, right? While exogenetic forces, they contribute to a micro landform. The area of the landform, the size of the landform that is created by the exogenetic forces is relatively small, right? Now you see Himalayas created by endo, तो ये क्या है? Macro है. And in Himalaya there is a gorge, right? There is a gorge, one depression is there. This structure is created by exo. The size of this gorge is relatively small. Therefore, most of the exogenetic force contribute to the micro landform. So this is our general understanding about the classification of landform. We classify into two, that is size and origin. Okay, now so how is the interior of earth? So look at this. What earth consists of? The outermost layer of the earth is known as crust, right? Crust is the outermost layer of earth. Okay. And what is lying inside? The interior of earth is known as geosphere, and from interior of earth is the origin of some force. This force is referred as endogenic or endogenetic force, right? Endogenetic force has the origin in interior of earth, right? Now what is this endogenetic force doing? This endogenetic force is going to impact crust, right? Endogenetic force is operating towards the surface. This endogenetic force is going to impact this particular location. It is impacting the crust. What is the role of endogenetic force? It is responsible for irregularity on the surface, right? Irregularity on the surface of the earth. Some vertical irregularity is created by the operation of endogenetic force. जैसे what this endogenetic force has done, it has uplifted this structure and there is formation of some irregularity. So it may cause folding, faulting, up displacement, this type of. So there is a crustal deformation. Concentrate. Crustal deformation caused by operation of endogenetic forces. Some irregularity is created, some unevenness is created by the action of endogenetic force. Now the question is whether these endogenetic forces are operating with the same intensity at all the places. Endogenetic force has the origin, right? Endogenetic force has the origin in interior of the earth. Is it operating? Is it operating with the same intensity at all the places? No. There will be places where the endogenetic forces are more intense and there are places where the intensity of endogenetic force is less, right? We'll see how this is related. So when we differentiate, so let us say the location A and B, at A the intensity is high and at B the intensity is low. This is known as crustal stability and instability. What is instability of the crust? Where the intensity and frequency of endogenetic force is high. Note there, crustal instability, crustal stability, right, in this way. Crustal stability is determined by frequency and intensity of the endogenetic forces. Frequency and intensity of endogenetic force. Where the intensity, don't write, where the intensity is less, such areas are known as stable. Where the intensity is more, frequency is more, that area is frequently experiencing endogenetic force, that will be known as unstable. So unstable crust and stable crust, these are the two concepts when we examine the tectonics on the surface. So what is the impact of endogenetic? Impact of endogenetic forces, some kind of variation, some kind of irregularity created on the surface, right? So we can see that this has been modified, the crust got modified here, some irregularity is created. Now what is happening on the, what is outside the crust? Sorry, outside the earth there is atmosphere, right? Then there is also hydrosphere. You can see there is exosphere, there is cosmosphere. In this way there are several spheres that are present outside the earth, and from outside there will be certain forces operating on this crust. These forces are referred as exogenic forces, right? Exogenetic means which has origin outside. Now can we say that all the forces exogenic forces, they originate in atmosphere. All exogenic forces have their origin in atmosphere. क्या ये statement correct होगा? No, right? Because there may be something like a meteoroid coming and falling on the surface of the earth. ये तो atmosphere से नहीं आ रहा है, ये तो it is coming from exosphere, it is coming from cosmosphere, right? But we can definitely say that majority of the exogenetic forces have their origin in atmosphere, right? Note there. Exogenetic forces have their origin in atmosphere, now see here, what is the tendency of the exogenic force? What endogenetic has done? Endogenetic has created some irregularity, right? तो ये जो irregularity है, this has been a result of endo, and if exo is operating, what exo will do? Exo will try to remove this irregularity and make this area what? Flat. Make it uniform. Means the tendency of exogenetic force is to suppress what? Relief. It is to modify the relief, bring down the relief. It is to degrade the landform, right? Degrade the landform. So which type of relief is modified by the exogenetic forces? Both absolute and relative relief is modified, and that area is getting converted into uniform surface. Thus, exogenetic forces cause degradation of landform. Can we write that? Exogenetic forces cause degradation of the landform, and they will try to bring down the landform to which level? Base level, right? They will try to degrade it and bring it down to the base level, convert that area into flat surface. Therefore, exogenetic forces are also known as leveling force, right there. Exogenetic forces have the tendency to degrade the landform, and cause reduction of both absolute and relative relief. Thus, they are considered as, exogenetic forces are considered as leveling force. Exogenetic forces are considered as the leveling forces, right? So, see here, this is the outermost layer of the earth crust is impacted by two forces, one coming from interior known as endo and one acting from outside, this is exo. ठीक है? Now, what endo is doing? Endo is creating some irregularity. Exo is trying to suppress this irregularity and make it uniform, right? Now, next question, whether exogenetic, now this is earth, can we say that there is a uniform or there is a presence of exogenetic forces throughout the surface of the earth? Can we say this? Can we say exogenetic forces are operating at all the places throughout? Yes or no? Yes, online students, can we say exogenetic force operate throughout? Yes, because throughout there is, in all the latitude there is what? Atmosphere. right? Atmosphere is there. Because of atmosphere, the exogenetic is operating in all the latitudes. And what is driving force for this exogenetic forces which are originating in atmosphere? What is driving energy? It is what? Two factors, insolation and the role of gravity. जैसे मान लीजिए, what is insolation causing? Insolation is causing the atmospheric circulation. You say there is a wind, right? Now this wind can blow the material from one place to other, can cause erosion from one place to other. The moisture that is transported may cause rainfall. Once there is rainfall, अगर यहाँ पर rainfall हो रहा है, what is happening to this water? Now this water will not remain here, right? Because under the influence of gravity, this water will start flowing. So there are two factors, two driving force for the exogenetic forces. What is that? Insolation and gravity, right? These are considered as the universal factors that drive exogenetic. So what is our understanding? That the exogenetic forces operate in all the latitudes, right? Because there is a presence of atmosphere. But are they operating with the same intensity? No, intensity of the exogenetic force will vary from one region to other. The capacity of the force also varies. The type of forces also varies. Now when it is equatorial or tropical, you can say here water is the agent of exogenetic force. In the polar region, glacier is the agent of exogenetic forces. So intensity of the exogenetic force varies latitudinally. ठीक है, I'll dictate, don't worry. Now, what can be, how we can understand that, how is the intensity of the exogenetic force in a given region? How is the intensity of the exogenetic force at a given location? What can be the interpretation of the exogenetic force? On what basis you can interpret the type and intensity of the exogenetic forces? This will be based on condition of climate. जैसे मान लीजिए this is the region of Africa. ये क्या है? The region of Sahara. What is Sahara? What type of climate Sahara has? Desert. Desert का मतलब high temperature and low rainfall, right? What is the exogenetic force here? The exogenetic force is caused by temperature, and the agent of erosion will be what? Wind is the agent of erosion. If it is humid, water is the agent of erosion. If it is a polar climate, glacier is the agent of erosion. So the interpretation of the climate is essential for knowing the nature of exogenetic forces, right? Got this? Right. So note there, the exogenetic force have uniform presence throughout the Earth's surface, but the intensity of these forces varies latitudinally. Next point, the interpretation of climate, this is important, the interpretation of climate is essential for estimating intensity and type of exogenetic forces. intensity and type of exogenetic force. Next point, the exogenetic force, all what I am giving now is important for prelims and statement based question, right? Next, what you have written? The exogenetic forces originating in atmosphere. The exogenetic forces originating in atmosphere are driven by insolation and gravity. Insolation and gravity. So insolation is the major source of energy that drives exogenetic force that originate in atmosphere. What is the driving source of energy for exogenetic? What is driving this mechanism is insolation. ठीक है. Second is gravity. जैसे मान लो ग्लेशियर है, तो ग्लेशियर, what the glacier does, the glaciers move down, right? What is causing this movement of glacier is a force of gravity. But how is glacier created? Glacier is created by operation of hydrological cycle, right? Hydrological cycle is a part of what? Atmospheric circulation, and atmospheric circulation is the product of temperature and pressure, right, and wind system, and this is indirectly governed by what? Insolation. In climatology you are going to study all this. So insolation and gravity, these are the two factor, and insolation is the source of energy for the atmospheric phenomenon. ठीक है. अब देखिए यहां तक क्लियर? What is last point you have written? Somebody is asking this. Driven by this, someone can read this. The exogenetic force originating in atmosphere are driven by insolation and gravity. ठीक. Now look at this. We have the surface, we have the force from geosphere endo, we have the force from outside is exo. ठीक है. What work endo does, this is known as rate of endogenetic, and how much work is done by exo, this is known as rate of exogenetic. So if I say rate of endogenetic force is equal to rate of exogenetic force, right? How will be the surface of the earth? It will be flat, correct? It is uniform if these two forces are operating in exact balance with each other. Just take example, if here is a volcanic यहाँ पर volcanic eruption हो रहा है, right? Volcanic eruption means the magma, lava will come out, right? And this lava is accumulating here, and there is the height of this structure continuously, one after the other eruption क्या हो रहा है? The height of this structure goes on increasing. Assume that this volcano has operated for nearly 1000 years. Number just for understanding, 1000 years this volcano has operated. In 1000 years it is able to create 1500 meter of relief, right? 1500 meter relief बना है in operation of endo for how much time? 1000 years. This is rate of endo. This is known as rate of endo. How much time it takes for creation of some structure. Now if I say that exo is operating on it, and exo brings this relief down to what? Base level in same period of how much? 1000 years, then we can say the two forces are exactly balancing each other. Jitna time is required for creation, in the same time if this is brought down, the two forces are operating in balance with each other, right? अब इसमें ऐसा तो है नहीं कि exo is going to wait for what? Endo to complete its work, right? Exo and endo will operate what? Simultaneously. There is equilibrium, but this is not static. Static equilibrium, what is meaning of a static equilibrium? Static equilibrium means one force is completing its work and the other force starts, right? But is it happening in this way on the surface of the earth? Is it that river saying that पहले आप अपना काम कर लो, right? River is not saying that first you uplift the landform and say that I have done my work, then I will start the process of erosion. River will start, is there from the beginning, right? Means what? These two forces will try to reach the condition of equilibrium by simultaneous operation. Therefore, which type of equilibrium exists between the two forces? This will be known as dynamic equilibrium, right? Are you getting the meaning of static and dynamic? Static is not practical on the surface of the earth. Static का मतलब क्या है? There is separation of endo and exo. This is not possible. You cannot separate the operation of endogenetic and exogenetic. There is always a simultaneous operation of endogenetic and exogenetic, and they will try to reach their equilibrium. But are they able to achieve this? क्या ये, are they able to achieve in the same period? No. Means what? The two forces do not have balance, right? So what is created in 1,000 years, let us say in after 1,000-year volcano has stopped its operation. From the beginning there was operation of exogenetic, but this exogenetic is not able to bring this landform down in 1,000 years. It will take 1,000,000 years for bringing this landform. It means that there exists an imbalance. Now what you see after, let us say 500,000 years, you see this type of structure. Means what? There exists one landform, right? And this landform is a product of, what is this landform? The evolution of any landform is a product of imbalance between endogenetic and exogenetic forces. Can we write this? Right? There exists an imbalance, and that imbalance is responsible for identity of any landform. How these two processes are competing with each other, this is going to determine the identity of any landform. Now you say endo is dominating. क्या होगा? Endo is dominating. See, there is rainfall in this region, right? There is rainfall, there is flow of water, but in spite of that the volcano has erupted, right? So what will happen? It will nullify the action of exo, and the height of this structure goes on increasing. Which force has dominated here? Endo has dominated. That is how the relief of that region went on increasing, right? Once the volcano has stopped, now what will happen? The exo will dominate and the height of this landform will go on decreasing. What force is dominating will determine the identity of landform. So what we can write, landform is a function of endogenetic and exogenetic forces, right? We got one principle of geomorphology. How is the identity of any landform? It is an interplay, competition between endogenetic and exogenetic forces, right there. So you can write in this way. Number one, landform is a function of landform is a function of endogenetic and exogenetic forces. Right. Next to write, the endogenetic and exogenetic force operate in dynamic equilibrium. They operate in dynamic equilibrium. Underline this, dynamic equilibrium means they are trying to balance each other with what? Simultaneous operation, right? They operate in dynamic equilibrium. ठीक है. Now take example. जैसे how was the formation of Aravalis? Aravalis were created 2.5 billion year before present. The Aravalis were created, and in last 2 billion year, what has happened to Aravalis? The region of Aravalis have remain crustally stable. Crustal stability. Crustal stability means there is no action of which force? Endogenetic has not operated. So what will happen? Which force will dominate here? Exo has dominated. See, Aravalis, when they were created, their height of this landform was even like more than 10,000 meter. And because of crustal stability, what is happening? There is no further upliftment. The height of the landform went on decreasing. What we see today, Aravalis are very low-lying structure. So what is Aravali? What is the identity of Aravali today? It is more a product of operation of which force? Exo, which has been degraded due to inaction of which force? Endogenetic. ठीक है. अब देखिए, where you look at Himalayas, Himalayas are like around 20 million year old, and Himalayas were created by the action of endogenetic force. Now this endogenetic force was, listen to this, endogenetic force was the result of collision of Indian land mass with Eurasian land mass. India collided with Eurasia, and that led to the action of endogenetic. This collision still continues. Means what? There is a continuous operation of endo, right? There is also presence of exo. River is there, glaciers are operating, climatic condition is operating, temperatures are there, all these are there. In spite of exo, in spite of presence of exo, what has happened to the height of the Himalayas? It is continuously increasing. This is indicating the dominance of which force? Endogenetic force has dominated in this region. So identity of Aravali is because of dominance of exo, where there is a crustal stability, while in case of Himalayas we say that it is more because of endogenetic. Exo is there, but exo is dominated by endogenetic. Thus the region of Himalaya is crustally stable or unstable? Unstable region. There is greater frequency and intensity of operation of the endogenetic forces, right? So now we are getting two forces here. So let us begin our discussion, or two principles we look at. First, you have written landform is a function of endo and exogenetic force. The second principle of geomorphology is landform is a function of structure, process and time, right? Two things are there. One you write. Number two, landform is a function of structure, process and time. Means two landforms are not identical. Two landforms are not identical because first principle, the endo and exo operating on the two landform might not be of same intensity, right? And two landforms are not identical because they may differ in their structure. What is structure? Is the geological composition of the landform. Geological composition means type of rocks. Type of rock. Now you see this is landform A and this is landform B. Now these two landforms are not same, as they are not identical. One may consist of igneous rock and another may be sedimentary rock. So rock difference is creating a difference in landform. If I say that both are igneous, but still the landform may vary because of what? Process. Process here is exogenetic and endogenetic processes. So both are igneous, but one is tropical, another is polar. One is tropical, another is polar, right? तो यहाँ पर क्या है? Rainfall is a process, here glacier is a process. So there is a difference in process, right? Now, if I say third, if even the process is same, here is rainfall, here is also rainfall, this is sedimentary, this is sedimentary. मतलब क्या है? Structure is same, process is same, but still there is a difference in rainfall. This will be because of both are affected or impacted differentially with respect to our time, right? यहाँ पर duration of the process here and duration of process here has varied, right? So one is in equatorial region. You understand in this way. One is in equatorial region getting rainfall throughout the year. One is in India getting rainfall only in monsoon, right? So there is a difference in duration of the process that is creating a difference in the landform, right? So why two landforms are not identical? So these two principles are explaining us this two. What is that? Complexity and diversity. What we started our discussion, that non-uniformity of the surface, non-uniformity of landform, complexity and diversity of landform can be addressed by two principles. Landform is a function of endo and exo. At all the places, exo is not same. At all the places, endo is not same, right? The combination of endo and exo will differ from one location to other. And second, there is a difference of landform because of their composition, because of the process, or because of duration of the process. Fine. This is clear? यहाँ तक clear है. So this is your basics of geomorphology. We have come to a conclusion about two major principles of geomorphology. These are foundation principles of geomorphology. One of the founders of this subject, that is William Morris Davis, he gave this concept of, this is known as a trio. For those who study optional, this is known as a trio of Davis. That is, landform is a function of structure, process and time. ठीक है? Clear with this? यहाँ पर कोई दिक्कत? Concentrate in class. If you are not concentrating in these two subjects, that is geomorphology and climatology. Oceanography is slightly short topic, right? But these two, these are conceptual. If you do not focus in the class, you will be struggling later on to interpret the things from NCERT or GC Lyon. You will not be able to interpret in the way it is required, right? From the books, right? Books में जो language है, NCERT is very assertion based. They only give you statement without giving any explanation, right? इसलिए class में it is important to concentrate and focus. Be alert in the class. Don't sleep. 7:30 है. Now, some are unconscious in the class. One fellow entered in an unconscious way from one batch to other batch, right? तो ऐसा मत करिए. You have to be alert. You should look at every point. We don't know from where the questions will be framed, right? You cannot afford to miss the things in these topics. ठीक है? Now, to begin with, let us see what is endogenetic force. We will take this equation as a reference, that is landform is a function of endo and exo. First we will study about endo, then interior of the earth, then geomagnetism, the sequence I have given you the topic, then we will shift to exo. First we will cover the numerator part here, right? So it is endogenetic. endogenetic forces. Endogenetic force. Now, what is endogenetic force? It is expression of energy derived from interior of earth, right? Endogenetic force is an expression of energy derived from interior of earth, right? See, some places I will start from the basic, right? So यहाँ पर now it is a test of your both patience and maturity. तो जहाँ पर topic some places when I am starting from very basic thing, this is for the students who are not aware about anything about this topic. Some students will be there who know this, right? तो that students may feel अभी यहाँ तो अरे ये तो पता है, तो ये तो पता है कि चक्कर में he diverts from, he goes somewhere else, right? So that fellows are at disadvantage. So you have to keep a track of that topic even though you know, right? So next, expression of energy derived from interior of the earth. Now expression and energy, and third is interior, right? Three topics are there. So how is the expression? How can be the expression of endogenetic forces? Expression will be a structural expression, right? How is endo expressed on the surface? Structural, जैसे it may create some feature, जैसे mountain, building, right? Upliftment of a continent, folding, faulting, this can be there. So can we say that this is simply considered as landform? So what is landform? Another definition of landform is it is a structural expression of endogenetic force, or it is expressed as a geophysical phenomenon. So expression of endogenetic force can be in two ways. One is structure or geophysical phenomenon. What is a geophysical phenomenon? This can be in the form of some catastrophic event, जैसे earthquake, or it is volcanic eruption, or it can be in the form of tsunamis. So geophysical phenomenons are also the expression of endogenetic force, right? Now, how much time this expression is taking? So we can classify the expression in two ways based on the duration. जैसे it is dystrophism. Dystrophism means this expression of endogenetic force has taken a long duration, right? We can classify or we can indicate this expression over a geological time. It has taken millions of years for the expression. Means this expression is relatively slow. Just take example, mountain building. Now Himalayas, they are not created all of a sudden. It has taken 15 to 20 million years for this mountain to be created. Continental drift क्या है? Dystrophic है. Plate tectonic dystrophic है. How is the movement of the plate? 15 centimeter per year is the rate of movement of the plate. Is it rapid? It is very slow process. These are all known as dystrophism, and opposite will be catastrophism. Catastrophism is where the endogenetic forces are expressed within what? Very short duration, and most of the geophysical phenomena Can we relate here? Geophysical phenomenon are which type of expression? Catastrophic expression of wind. How is earthquake? All of a sudden volcanic eruptions are also within a very short time. Tsunamis are also very short time. These are considered as catastrophic. Now tell me, majority of the earth's surface features are the product of catastrophism or diastrophism? Majority of the earth's surface feature, configuration of the earth is a product of what? Diastrophism. जितने भी आपको लैंडफॉर्म दिख रहे हैं आसपास, majority of them have been evolved by the process of diastrophism. Right there. The configuration of earth's crust, configuration of the earth's crust is a product of diastrophism. Configuration of the earth's crust is a product of diastrophism. Now, what we have learned, endogenetic force is an expression of energy derived from interior. We got idea of expression. Now look at what is the source of energy. The next quest is, what is the source of energy that is driving endogenetic forces? Right. Now we will try to find the answer for this. That is, what is driving endo? What drives exo? What is driving exo? We know the answer for that, right? That is insolation. Atmospheric phenomenon is driving the exogenetic. We'll try to find the answer for what is driving the endogenetic force. Right. Now for this, we'll consider first some facts about Earth. Right. So knowing about Earth. Earth as a planet, age of Earth is 4.6 billion years, right? Some factual information you write. Age of the Earth 4.6 billion year. Radius of Earth is 6,400 kilometer. Round figure. 6,400 kilometer radius. Average density of Earth is 5.5 grams per centimeter cube. This is the average density of Earth. Origin of Earth is from primordial matter. I'll explain this. Primordial matter, this is PMM, is primordial matter that resulted in formation of Earth, and temperature of Earth at origin. When Earth was created, the temperature of Earth, estimated temperature of Earth from radioactive isotope decay, right? We are estimating a temperature based on radioactivity. This is around 6,000 degree. This was the temperature of the Earth 4.6 billion year before present. What is this 4.6? See, I am writing here billion year before present and million year before present. इस तरह से I will be using this two throughout our discussion. So BY is billion year, MY is million year. So 4.6 billion year means it is 4,600 million year. This is the history of Earth. This period is known as geological time, right? History of Earth is known as geological time, which is further divided, right? Further divided into small intervals, that is known as geological time scale, right? Geological time scale. अब देखिए, now composition of earth. What is earth composed of? Composition of earth. Now, composition of the earth, it consists of the gaseous elements, like it is oxygen and carbon dioxide, hydrogen, oxygen, carbon dioxide, hydrogen, and nitrous oxide and other gases. Most abundant is oxygen, right? Abundant element in interior of the earth, like highest proportion wise among all is oxygen, right? So oxygen is the most abundant element in interior of earth, right? Other elements consist of, what is other? This is iron, that is Fe, which is present. Then it is silica, then it consists of aluminium and magnesium or manganese, and then it is nickel. ठीक है? So Ni is nickel and here is Al, this is silica, Si. Right. In this metal, heavy metal, क्या है? Iron is heavy metal. Heavy metal is iron, and nickel is also heavy metal, while silica, aluminium and magnesium are relatively lighter material. ठीक है? Denser, इसमें density किसका ज़्यादा है? Density is, iron is denser, right? It is heavy, and nickel is also heavy, right? Silica, aluminium, magnesium, these are relatively lighter material, and silica is a poor conductor of heat, right? It is semiconductor, it is a poor conductor. Metals are a good conductor of heat, right? Apart from this, we also have radioactive elements present in interior of the earth. So radioactivity, we'll write it as R, right? This consists of radium and uranium. These are the radioactive elements present in Earth's interior, right? Radium and uranium, these are radioactive elements. How is radioactive element? These radioactive elements are heavy or they are dense, stable or unstable? They are unstable, and they will undergo, this is continuously undergoing decay, and this decay is going to produce heat, right? So wherever radioactivity is present in interior of the earth, this radioactivity will produce heat, right? Radioactivity is producing heat. Wherever it is present, this will cause increase in temperatures, right? Now this is overall composition of earth. This is not the composition of crust alone, right? So highest proportion is oxygen, but it is not independent existence of oxygen. Oxygen is combined with silica, like silica oxide, magnesium oxide. In this way, it creates oxide in interior of earth, right? It creates a compounds like feldspar by combining with silica. So in this way, this is the general features of the earth. Now, how earth was created? How earth, magnesium, right there, Mg is magnesium. Magnesium silicate, it is combining with silica, that is known as magnesium silicate, right? Now, how is the formation of earth? Earth was formed by a primordial matter. Now concentrate from here. Primordial matter. What is a primordial matter? Primordial matter was a cosmic dust that was existing before the formation of a solar system, right? So initially what was there? This was a cosmic dust, or it is a nebula of a cosmic dust, a rotating nebula of a cosmic dust. In this way, this was huge quantity of a cosmic dust present, and this was rotating in place of what? Solar system. Means the entire solar system was evolved from this rotating nebula of a cosmic dust. We are talking about something like 6-7 billion years before present. Earth came into existence around 4.6 billion years before present. Okay? So what has happened here? This cosmic dust or nebula was experiencing two inertial forces of universe. What is this inertial force of universe? There are two forces. One is the centripetal force and centrifugal forces, right? Means one force always act. Any cosmic body is experiencing this force, right? This is experienced by every cosmic body, whether it is a satellite or a planet or a star or a galaxy, everything is going to experience this force. We are still trying to find out the reason for this force. One theory that is explaining this is Big Bang theory, right? So यहाँ पर we will consider the two forces. One force acting towards a center of the body, that is known as centripetal. This also can be considered as origin of gravity, and one force which is a counterbalancing force, which is known as a centrifugal force. अब ये force सब body पे applicable है, right? And these are known as inertial forces of universe, which make the things in the universe to get arranged in a particular format, right? जैसे you find all the planets are revolving around sun, satellites are revolving around the planet, sun is revolving around the axis of Milky Way, Milky Way might be revolving around some other axis, right? All combinedly might be revolving around some other thing, right? So that is how we can look at the origin of this inertial force. We'll take this as a reference, ठीक है? यहाँ पर this is still a matter of research. What is two things are there. Two, where we are still doing research is what is a fundamental particle of universe, that is known as God's particle, है ना? उसके लिए कुछ experiment चल रहे हैं, that is CERN and all that is there. Higgs boson, right? And second is what is this inertial forces of the universe, ठीक है? हम इसको apply करेंगे. So when these forces have operated on this cosmic dust of nebula, what has happened? The result of this was most of the centripetal force has concentrated or consolidated the material at the center, and nearly 93% of this material got consolidated to form what? To form sun. तो ये कंसोलिडेट हुआ है सेंटर में. एंड व्हाट अबाउट रिमेनिंग 7% ऑफ द मटेरियल? दिस 7% ऑफ द मटेरियल वाज थ्रोन अवे फ्रॉम दिस सन with the help of which force? Centrifugal force. And this got arranged, this material got arranged in the form of what? Orbits around the sun, right? So there is a material moving in this orbit. ये क्या था? This was some primordial ये है primordial matter, right? This was rotating and revolving around the sun. ठीक है? So in this way, when this material is thrown out, what is happening to the density of this material getting arranged in the orbit? As we move away from the sun, the density goes on decreasing. Higher density material is arranged near the sun. So first 4 orbit is having high density material, later 4 is having low density material, and in every orbit ये material क्या है? Because the size was different, this went on moving with a differential velocity. At one point of time, these materials started colliding with each other and got consolidated to form what? Planet. In this way, Earth also came into existence by collision of the primordial matter. तो क्या हो रहा है? First 4 planet, the density will be higher. Next 4, the density is low. This was the result of differential centrifugal force acting on this material, which got separated from the sun. Thus, we classify the planet as inner and outer, terrestrial and gaseous planet. So, formation of the planet was the result of consolidation of the primordial matter, right? So, this you have written, write in stepwise. First, inertial forces, right? Inertial forces, centripetal and centrifugal force. Formation of planet was by consolidation. Formation of planet was by consolidation of the primordial matter. Consolidation of the primordial matter in its orbit. Consolidation of the primordial matter in its orbit, right? Now, in the orbit of Earth, what is happening? So, this was initial, assume that this was initial primordial matter. What has happened? One more such mass came here and collided with it. Size got increased. One more collided here. In this way, it went on colliding and this structure went on increasing in size because of the collision. Because of collision, what is happening to the temperature of this? Went on increasing, right? This is how it reached the maximum temperature of 6,000 degrees, right? So, initial temperature of the earth was very high, and this temperature was the result of collision. So, primary reason for such a high temperature to be existing during the formation of the earth was the collision of the primordial matter. Now, this material which was coming towards the earth, now this is something like a small meteorite kind of thing which is coming closer and then getting consolidated. What this material have brought along with it? They have brought lot of gases along with it, right? So, in this way, one of the gas that got emitted out through all this material during consolidation was oxygen, right? In this way, the proportion of oxygen, initial proportion of oxygen was increasing, right? It went on increasing, and some of this material also brought hydrogen along with it, right? And this hydrogen and oxygen went on combining, and there was formation of water vapor. So, we can see some traces of water vapor existing during the formation of earth itself, right? But this was in very small quantity and present at, was it present closer to the surface? No, it is not possible because the temperature was so high, this water vapor was present at greater height. That is why we say the water vapor that is present on the earth, the water that is present on the earth is as old as earth itself, right? So this cosmic bodies, when they were getting consolidated, they also created, because of the gases present along with them, they also created some traces of moisture, traces of water vapor, right? This. So consolidation of the primordial, right, point wise, consolidation of primordial matter was accompanied by formation of water vapor, and release of oxygen. Thus, next point, thus water of earth is as old as earth itself. Water of earth is as old as earth itself. So we can see some traces of water because of this cosmic material getting consolidated, right? अब क्या हुआ है? All this, it was around 4.6 billion year before present. Now there was formation of one structure. This completely got consolidated, and this was with a temperature of 6,000, right? 6,000, and it was a burning ball that time. And but is it spherical? No, it was irregular in size. So irregular in shape and size, and it was in which state? Solid state? No, it was semi-solid with lot of gases, right? Gases present around it. What is this structure referred as? This initial raw earth that came into existence 4.6 billion year before present is known as blob, right? This is known as blob. ये blob था. So now blob is also acted upon by, this is a blob. Blob is also experiencing what? Two forces, in centripetal and centrifugal, and blob is revolving around the sun. So there is revolution, rotation with these two force. What is happening over a period to this blob? This is getting changed, or this is getting modified, and this is gaining the shape of geoid, right? So it was a transition from blob to geoid, right? Transition from blob to geoid. This was because of what? The inertial forces and rotation, revolution, and centripetal and centrifugal force. Over a period, they modified the shape of this blob and converted into a spherical structure that is known as a geoid. ठीक है? अब देखिए, ये blob जो है, इसका temperature कितना था? 6,000 degrees was the temperature, and initial temperature was high. This was a product of collision. Once all this material got consolidated, what this blob was doing? Now it started losing heat, right? Losing heat. The temperature of the surface went on decreasing, right? So ये decrease हो रहा था. So during this period from 4.6 billion year to 4 billion year, this period, we can see this is known as Hadean eon. Eon is one of the divisions of geological time, right? Eon, era, period, and epoch. We'll see that. So This period 4.6 billion year to 4 billion year, this is known as Hadean eon, right there. During the Hadean eon period is 4.6 to 4 billion year. to 4 billion year, right. Earth went on, number one, Earth went on losing the heat, and the surface temperature of Earth were declining, right. Surface temperature of Earth were declining. ठीक है. What was the reason for initial temperature? क्या था? 6,000. How it has gained that 6,000? Collision, right? Collision was the reason for initial temperature. After it got consolidated, it went on giving away the heat, right? Now, it was around 4.5 billion year before present, right. 4.5 to 4.4 billion year before present. In this period, this blob, there was a huge cosmic body of the size of Earth itself, we can say. This was known as Thea, Thia, Thea, named after a Greek god, right. Hadean is also a name of a Greek god, right. So, a Thea came closer to the Earth and collided with Earth and went out, right. So, ये क्या हुआ है? It was an impact caused by Thea. This is known as a giant impact, right. Giant impact has occurred in this period. In Hadean itself, the period of giant impact is around 4.5 to 4.4 billion year. I am giving a range here because some NCRT it is a different data, and for NASA has a different data here. So, it is 4.4 to 4.5 billion year. This period was a period of giant impact where Thea collided with the blob, right. Abhi ye blob kya tha? Still it is in which state? Semi-solid. It was semi-solid burning ball. When this Thea collided and went out, what is happening? A huge material of the blob was ejected out, right. और ये material क्या है? It started consolidating around the blob and then started revolving around the blob itself, and this is how was the formation of moon. Moon was created, right. So, moon was the product of giant impact, right. Moon is a product of giant impact. So, material of the moon is derived from where? Earth itself, right. That collision of the Thea with the blob ejected a huge quantity of material, and the result of this क्या होगा? Because of this, one depression was created on the blob, right, and this depression might have remained as irregular structure of the Earth somewhere, which later on got filled with water, and we can see this evidence of such collision on the floor of Pacific Ocean, right. So, floor of Pacific is providing us the evidence of this giant impact, right. When it is colliding in this way, so what is happening to the Earth or what is happening to the blob? It slightly got tilted, right. It slightly got tilted. This is how it was able to gain its angle of tilt, that is around 23.5, right. So, this was the two things that has occurred in Hadean to the Earth. One is giant impact right? Giant impact created a huge depression on the block and there is formation of moon. That is, meaning is 4 billion year before present. Where was this moon? So if you see here, this is earth and this was the moon, right? And today where is moon? Moon is here, right? And in future where will be moon? It will be here. Means what? We can see the distance between, because of that force that ejected out the material, that force is still operating. It means that the orbit of moon is expanding. The distance between the earth and moon is increasing. Every year we can see that it goes slightly away from earth. This is the result of that inertial force of what? Of the giant impact, right? So note there is expansion of moon's orbit. There is expansion of the moon's orbit and the distance between moon and earth, is increasing, right? Distance between moon and earth is increasing, right? Now it was around 4 billion year before present, right? 4 billion year. Now 4 billion to 2.5 billion year. This period is known as Archean eon. वो क्या था? 4.6 to 4 was Hadean, right? This is known as Archean eon, right? Name is important. तो यहाँ पर अब क्या हो रहा है? At 4 billion year, how was the earth? Earth was, now we can see most of the part of the earth now gained its shape, right? Most, like, it was becoming more and more spherical. It has not remained that irregular, right? It is moving towards what? Geoid, right? ये geoid की तरफ move हो रहा था, and that is how the shape of the earth was more or less spherical. What about temperature of the earth? The temperature of the surface of the earth was not 6000 now, it went on decreasing. The temperature of the earth's surface was less than 1000 degrees. यानी 6000 से आसपास you can see 1000, right? It is coming closer to 1000 degree, and wherein the surface of the earth is still in which state? The surface of the earth is still in semi-solid. अभी भी ये semi-solid state में था, and what is present outside? There was huge quantity of oxygen present in the outer part of the earth. ठीक है? Now what was not allowing the temperature to decrease that rapidly? You can see 4.6 to 4 billion year, means half a billion year it has taken for this temperature to drop. The decrease in temperature was very slow, right? What was not allowing the temperature to further decrease is near the surface. So how it is? If you see the crust here, what was there near the surface? This is a geosphere. The surface was having lot of what? Radioactive elements. It was also having lot of iron. It was also having nickel. These type of elements were there near the surface. जैसे you say radioactivity is there near the surface. You have uranium here. तो uranium या radium अगर यहाँ पर रहेगा, what this radium and uranium will do? They undergo decay, right? And if they are decaying at this place, they continuously contribute to what? Heat, not allowing the material to cool, right? The temperature of this place remained what? High, right? Now, but what has happened? because of this force, which force? Centripetal force, all this high density material, we are talking about which period? Around 4 billion year, 4.1 to 4 billion year, all this high density material got transported towards the center of the earth. मतलब क्या हुआ है? High density में क्या आएगा? Radioactive elements were shifted towards center of the earth. All the iron was shifted towards the center. All nickel was shifted towards the center. What was left on the surface? There were gases, lighter element, gases. There was silica left on the surface, aluminium left near, and magnesium left near the surface. What is this? This is known as density adjustment, right? Density adjustment was possible during that time because entire earth was flexible. Yes or no? It was semi-solid, right? It was semi-solid. All because what is the force responsible for? Density adjustment. Density adjustment was the result of which force? Centripetal force, which transported all the high density elements. They got now concentrated at which region? What we call today as core of the earth. That is why today, what is the configuration of earth's interior? The configuration of earth's interior is Sial, then Sima, and what is here? Knife, and knife plus what? R, right? What is there at the core? Core is metallic, right? Core is metallic, and all highest concentration of metal is at the core. Highest concentration of radioactivity is also at the core. तो यहाँ से जब ये radioactivity shift होगा, what will happen to this temperature? Now uranium जो यहाँ पर heat generate कर रहा था, that has been shifted down, right? Now there is no source of heat. The temperature now started rapidly decreasing, right? Decrease in temperature. Now this is clear. So what has Earth experienced at the start of Archean? We are talking about 4 to 4.1 billion year before present. There was density adjustment. What is density adjustment? High density material shifted towards the center of the earth. Today the configuration of the earth appears to be Sial, Sima, knife. Sial is denser or lighter material? Lighter, silica, aluminium. At the top, slightly denser is Sima, that is magnesium silicate, and then metal which are heavy, radioactivity which is heavy, all that got concentrated at the core, right? Note there, the start of Archean eon. The start of Archean eon was characterized by density adjustment. Start of Archean was characterized by density adjustment, in which all the high density elements were transported towards the center of earth. Were transported towards the center of earth. Next point, the configuration of earth's interior. The configuration of earth's interior got organized as what? Sial, Sima, and knife. Got organized as Sial, Sima, and knife. Next point, core of earth has highest concentration of highest concentration of metals, heavy metal, that is nickel and iron, and radioactive elements. Highest concentration of metals and radioactive elements. Thus, the temperature of core क्या होगा? High. The temperature of core is very high. In bracket, same temperature will take for the core also now, that is 6000 degrees. So, temperature of the core is very high, it is up to 6000 degrees, and core produces heat because of क्या? Radioactive decay, right? Core produces heat because of the radioactive decay. This is known as geothermal heat. This is known as geothermal heat, right? So where is heat produced in interior of the earth? At the core. And why is core producing heat? Because of radioactive concentration. Why core has radioactivity is because of density adjustment that has operated around 4 billion year before present. अब देखिए, so 4 billion year, what is happening to the crust? All the radioactive elements that were there at the surface have been shifted. The temperature of the surface now went on rapidly declining. जो 1000 के आसपास था, it went on decreasing like 800, 600. As the temperature went below 800 degrees, what is happening to the material of the outer layer of the earth? These started getting converted into solid, and this was the beginning of formation of lithosphere, or we can say it is the formation of the crust. So it is the solidification and formation of what? Rocks, right? Formation of the rock. Now when this process of lithosphere या solidification चल रहा था, we are talking about 3.9 billion year before present, the lithosphere got organized. मतलब ये solid हुआ है, and during this process of solidification, whatever gases were trapped in the outer layer, अब तो gas तो यही था, है ना, जो because gases are what? Lighter element, they were left behind near the surface, denser have moved towards the center. All these gases were released during solidification, and this process is known as, this was known as what? Degassing. Degassing क्या है? It was a large scale escape of gases during the formation of the rock. ये आज भी होता है, but this is on small scale. If there is a volcano erupting, you see a magma or lava coming out. जब ये lava solidify होगा, whatever trapped gases are there inside, that will escape. But this was happening almost at all the places on the surface of the earth. Degassing was a large scale phenomenon which added to the surface of the earth which gases? Carbon dioxide, hydrogen and nitrous oxide. What was already present? Oxygen was already present, right? Now this degassing resulted in all these gases, and they started accumulating near the earth. This was the birth of primary क्या था? Primary atmosphere. In this way, atmosphere came into existence, right? So what is the atmosphere of earth? Right, atmosphere of earth is the envelope of gas. Where is these gases derived from? Is it exogenic? क्या atmosphere exogenic है? Is it that somebody has placed the atmosphere on the earth? No, atmosphere is endogenetic. Most of the gases that are present, even oxygen also was brought by the primordial matter, right? Most of the gases that are there in the atmosphere have their origin in interior, right? So atmosphere of Earth belongs to Earth. Atmosphere of Mars belongs to Mars. Atmosphere of Venus belongs to Venus, right? That is how what is the composition of the planet will determine the atmosphere of the planet. That is why every planet has unique atmosphere, right? अगर कोई place कर रहा होता, if somebody is placing atmosphere from outside, he or God or force of nature might have placed the uniform atmosphere for all the planet, लेकिन ऐसा हुआ नहीं, right? Atmosphere is endogenic, it is unique for every planet. Most of the gases that are in the atmosphere of that planet is derived from interior of it, right? Same is applicable for Earth also. What is the mechanism for formation of atmosphere? Degassing, right? और ये जो atmosphere बना था, we are talking about 3.9 billion year. What is it emitted out? Huge quantity of what? Carbon dioxide was very high, nearly 40% of carbon dioxide. Hydrogen was given in huge quantity, lighter gas है, given in huge quantity, but hydrogen immediately found a companion, right, oxygen, and that led to increase in proportion of what? Water vapor. Traces of water vapor was there, right? That was from the, but that is not, that was very less, right? Now the water vapor went on increasing in the atmosphere, and because most of the oxygen that was inertial oxygen was utilized in formation of water vapor, क्या हुआ है? The proportion of independent oxygen in the atmosphere went on decreasing. तो oxygen क्या हुआ है? Decrease हुआ है. So Earth experienced which condition? Hypoxic condition, right? Hypoxic condition means most of the oxygen that was there initially was utilized in formation of water vapor. Oxygen proportion went on declining, and the end of Archean, that is 2.5 billion year, saw the evolution of life on the surface of the earth. लेकिन जब life evolve हुआ है, it evolved in absence of oxygen, low proportion of oxygen. That is how we say the evolution of life was anaerobic respiration, right? पहले क्या था? Anaerobic, then got shifted to aerobic, then photosynthesis and all that you are having, right? So hypoxic condition, and this was with low proportion of nitrous oxide. This is primary. अब ये बताइए, what is the present composition of atmosphere? Present क्या है? Nitrogen is there, then oxygen is there, then carbon dioxide is there, and then water vapor. Exactly opposite है ना? So which is low is high here, then this is higher, this is very low, this is lowest, right? Means the atmosphere has evolved from what? Primary. This is primary atmosphere. Today's atmosphere is known as secondary atmosphere. There is evolution of atmosphere from primary to secondary. Initial atmosphere जो create हुआ था, इसका composition is completely different. It was having water vapor, carbon dioxide, oxygen in small quantity, and nitrous oxide in very small quantity, right? Note there. This you have written right there. The formation of primary atmosphere, formation of the primary atmosphere was by the process of degassing, in bracket, large scale escape of gases, during the formation of rocks or lithosphere. Write this. Primary atmosphere was composed of water vapor. Now water vapor also was created, right? How it was created? Hydrogen and oxygen. Water vapor, carbon dioxide in large proportions, water vapor and carbon dioxide in large proportion, and oxygen and nitrous oxide in declining proportions, means low in quantity. Next point. The primary atmosphere has evolved. The primary atmosphere has evolved with the change in composition. Primary atmosphere has evolved with the change in composition to the present secondary atmosphere. Right? Now where we are? It is around, what is the period? 3.9 billion year before present. क्या हुआ है? The lithosphere is there, atmosphere is also there, and the surface temperatures are low, and you can see the surface temperature going as low as 400 to 300 degrees, right? This was the surface temperature. See, less than 800 it will solidify, less than 800 it is going to solid. These are optimum temperatures required for solidification of the rock. More than 800 the material generally exists in semi-solid state. ठीक है, तो ये 800 to 700 this can be considered as a benchmark. अब यहाँ पर what is there? Huge quantity of water vapor is there. So lithosphere, atmosphere and water vapor. Now these water vapors started getting consolidated, right? Consolidated, condensed, formation of the cloud, and this cloud is now giving rainfall. This raindrop is traveling towards the surface, but temperatures are 400. Ye 400 is still higher for a rainfall to occur, right? What will happen to this raindrop? It is evaporated in its path itself, again shifted back. This went on accumulating, and this cloud was increasing in size, right? The water vapor getting circulated and the cloud watching down, right? And waiting for क्या? The temperature to further decrease. जब ये 300 हुआ है, it came little bit closer. With 200 it still came closer as the temperature went on decreasing less than 100. This has happened around 3.8 million year. The start of 3.8 million year, the temperature on the earth's surface were less than 100. Now all that was collected for millions of years started raining up to the surface of the earth, and this has operated for nearly 40,000 years. It took 40,000 years to release all that was collected into the atmosphere, and this went and got settled on the surface of the earth, and this is the formation of which sphere? Hydrosphere came into existence, right? So this is how a cycle of precipitation, rainfall that has operated for nearly 40,000 years emptied the atmosphere. What is happening to the water vapor quantity in the atmosphere? Went on decreasing, and today we see only small traces of water vapor in the atmosphere. All came down. Where is water vapor of this primary atmosphere going? Where it has gone? Today it is present in the form of what? it is present in the form of oceans, right? So note there, the cycle of precipitation, that has operated around 3.8 billion, not million, 3.8 billion year before present. 3.8 billion, correct that. 3.8 billion year before present has resulted in formation of hydrosphere, and stabilization of Earth's surface temperature. Formation of hydrosphere and stabilization of Earth's surface means what? Further temperature, because of all this water, further temperature went on decreasing and it got normalized, what we see the present temperature. Now this was the platform made for existence of life, right? In that way later on life, end of Archean, saw the evolution of life on the surface of the earth, that is around 2.5 billion year, that is known as Proterozoic. The life will start after that, that is known as Proterozoic eon, right? So eon 4 हैं, 4 eons are there. One is Hadean, क्या है? 4.6 to 4. Second is Archean, right? So it is in this way, Hadean eon, right? Eon is one division of geological time. Hadean is 4.624 billion year before present. Then it is Archean, 4 billion to 2.5 billion year before present. Then Proterozoic, it is 2.5 billion year to 541 million year before present, means 0.5 billion year before present. 2.5 billion to 541 million year before present, Proterozoic, and Phanerozoic, this is 541 million year to क्या अभी जो चल रहा है, that is known as Phanerozoic. तो यहां पर देखिए, we are using a word what? Zoic, right? This is zoic. ये जो दो है इसको हम बोलते हैं azoic. Azoic का मतलब है where life has not existed, right? Here life has existed, right? So in this way, in a sequence we are having this. Hadean. How was Hadean? Hadean is the Greek meaning of Hadean. Hadean is a god and Hadean is a caretaker of hell, है ना? तो इस टर्म से डिराइव हुआ है, caretaker of hell. और hell में क्या चल रहा है? Right, we are having lot of fire, volcanoes, eruption, right? People are burning there, right? सबके कबाब बन रहे हैं. तो इस तरह से, so we have hell there. So that kind of situation was there from 4.6 to 4 billion year before present, right? So this is eon. We'll see this, but I'm just giving you idea because you can correlate here. So Hadean, Archean, Proterozoic and Phanerozoic. What is difference between Protero and Phanero? Here the life was simple life form, जैसे unicellular, algae, small grass, plants, arthropods, aquatic organisms. They evolved during Proterozoic. Life became more complex in Phanerozoic. Large organisms, right? Large trees, large plants, vertebrates, mammals, reptiles, all they came into existence in Phanerozoic. ठीक है. So this is how we see how is Earth and the sphere of the Earth evolved. So we have seen from this one, that is how was the nebula and how the Earth is evolving in this way, right? This is how it is: lithosphere, then atmosphere and hydrosphere came into existence. What was the topic? Topic is to find source of energy, right? So topic is this, right? So finding the source of energy for operation of endogenetic force. We got that, right? What is the source of energy that is driving the endogenetic force? It is the geothermal heat, right? And how is this geothermal heat produced? By where it is produced? Core, and it is transferred towards the surface, and this becomes the source of energy that drives the endogenetic forces, right there. The geothermal heat produced at the core, is the source of energy that drive endogenetic forces. Next point, the mechanism of heat transfer will determine mechanism of endogenetic force. Will determine the mechanism of endogenetic force. Now, I hope it is clear. Where is energy concentrated in interior of the earth? Core is producing energy, and this energy now is to be transferred. What will transfer this heat will also determine endogenetic force, right? Whether it is a radiation, conduction or convection. The mechanism by which the energy is going to, this geothermal heat is going to get transferred, this is going to determine the operation of the endogenetic forces, right? So this is the topic of endogenetic. Now we have to discuss about how is this energy transfer mechanism. So that part we'll do in next class, right? So we'll learn about what is convection, how is thermal convection created, and then we'll see what is interior of earth, right? Topic is not over. You read this, and after next class you will get a better understanding about how this endogenetic force exactly operate, right? Fine. Clear, online students? Go through this topic. After next class we can take up the doubts.